So, Jeff, you're kind of in the center of the shoe universe. I mean, you just mentioned you have I don't know how many years um, of selling shoes, modifying shoes, wearing shoes. And it's an interesting time because we're recording this September 2020, and over the past year or more, it's been all of a sudden a lot of controversy around shoes in the competitive distance running world with the introduction of certain types of carbon plates inside shoes, and there's this whole question of at what point is shoe technology um, an unfair advantage? Is it? I mean, where do you draw the line? Can you just run a marathon on roller skates? Like, what's so? There's this kind of somewhat ethical debate around shoes and what's acceptable. They're starting to draw lines around what's acceptable in major marathons, things like that. So, I guess first of all, to start this part of the talk off, can you just say a little bit about, like, just generally, like, what is your general philosophy of around what a running shoe should be?
All right. So that said, this is a great topic, and we could go on for days on this one. But this is I'm in the shoe business. I sell shoes. So what I'm about to say, don't, it's going to sound a little weird. But I think the greatest of all engineers, created us, and he didn't make a whole lot of mistakes. So our feet are pretty well designed. So I think the most efficient way to run is to run like you're barefoot, but with a shoe on, because we can't run barefoot on asphalt, concrete, sand spurs, nails, glass, so on and so forth. And we weren't meant to run. We weren't meant to run on pavement and concrete and all these surfaces that we run on. I mean, our bodies weren't designed for that. Now you say, oh, the Tarahumara Indians down in Mexico, well, they run barefoot. Well, they do, but they actually have very flexible foot structure. We can get into that a little bit later, but most of us of European descent have a more rigid foot, okay? Well, more rigid feet don't absorb as much shock. So you better run on a soft surface if you're going to run barefoot. But a more flexible foot can run barefoot on harder surfaces. All the Tarahumaras and, say, the East Africans do run a lot on soft surfaces, clay and so on. So when it comes to shoe design, I think a shoe that tries to enhance the characteristics of the barefoot are the way to run. In other words, you don't want a shoe that inhibits that motion. Now, don't get me wrong. I'm not talking about medial and lateral motion. I'm talking about forward motion. When we're running, we're going in a forward motion. We're not playing basketball. We're not playing tennis. We're not going from side to side. So we want a shoe that encourages that forward motion. On the other hand, if someone has problems like, quote, overpronation or underpronation, supination, maybe we want to address that by giving them some structure on the medial or the lateral side. But when we start to inhibit that forward motion, we start to work. Those 33 joints in the foot are meant to articulate, which that articulation absorbs shock, and it propels the body. When we start to inhibit that, we start to make the body less efficient. Example, myself, I've raced quite a lot barefoot because shoe technology has come so far. When I started running, shoes were not anywhere near like they are today. We didn't have the foams we did and so on. And wearing shoes sometimes was an inhibiting factor. I actually raced, like I say, barefoot. And if anybody can remember the incident in 1984 where Zola Budd connected with Mary Decker on the track, and Mary Decker fell, and she was America's darling, and the South African Zola Budd, who tripped her up, was running barefoot. So anyway, back to what I'm saying is, if we can make the foot more efficient and function like it's barefoot, but give it a little bit of cushioning and a little bit of better traction, I believe that's the way to go. But now, that said, I actually have worked on shoes since the 70s, trying to make shoes make somebody faster. And I started working on shoes and selling shoes in 1978, where I would not only work on my own shoes, I'd work on friends' shoes and customer shoes and so on. And what I learned is, running on indoor wooden tracks, I found that some people could actually run faster on these raised wooden tracks than they could on a non-raised wooden track. And a raised wooden track has support structures. And so if the people that could run efficiently on boards would sometimes get more bounce off the boards. So for years, I tried to create shoes that would give you more bounce, whether it be with foams, whether it would be gluing a suspended net under the foot to work like a trampoline. I did all kinds of stuff to make it better. I took foam from toys, for instance, which other people have done too. I took foam out of toys and put them on the bottom of shoes. I took the soles off of shoes, and so I was just running on the foam. Lots of different things to actually be faster. But in the early 90s, I started working on using composite fibers, which means fiberglass, carbon, Kevlar, graphites, and so on, trying to create something that would actually propel you faster. And I was actually worked extensively in this field. It had been done before. People had tried carbon fiber, for instance, but it was unsuccessful, made shoes stiff, made people have Achilles injuries and so on. But I was able to be pretty successful with this. But at the time, I couldn't get a manufacturer on board with it because they'd have to retool up their factory, and it would be a very expensive process. But to give you an example, I was able to build shoes with glass, fiberglass. If you think about a pole vault pole, the fibers can elongate and contract. So when what's his name, Bob Segrin, was jumping the pole vault, I'm not going to know the exact figures here, but in 1968 they invented fiberglass poles. Before that, basically poles did not flex; they were kind of like stiff levers. The fiberglass pole, you'd plant the pole, it would flex, the fibers would elongate, and then they'd spring you forward over the bar. Okay, so I learned quickly that carbon fiber, graphites, Kevlar, and so on could give you structure and support, but fiberglass fibers could elongate and contract and actually propel you forward. And I built several shoes out of glass. I actually had several manufacturers make some prototype samples. And here's a good example. Some friends of mine were trying to break 3 hours of the marathon at the Tybee Island Marathon in Georgia. And I said, well, here, let me go down with you and I'll pace you so you can do that. Well, I wore a pair of fiberglass shoes that I had built. Now, they were still in a crude stage. Remember, I'm building these in my garage. And I was at a point where I still hadn't figured out the proper bonding to make bonds that were flexible enough because the bond goes through a lot of stress. But anyway, so I ran the marathon with them, and yes, we broke 3 hours and all that stuff. But the next day, which was shocking, is I was able to go out and run a hard 10-mile workout. And most of you who have run marathons understand that the day after marathon, sometimes you can't walk downstairs. But I was able to do that. And it made me realize that I was really onto something here. Not only was running, that wasn't a fast time for me or anything like that, but I was able to run with very little effort with basically springs on my feet. And because the fiberglass worked as a decelerating factor, like the muscles that are usually involved in decelerating the body were no longer used, I wasn't as sore the next day. So, on and on, I've learned a lot. But yeah, we're in a time right now where we're talking about, can shoes make you faster? Oh, absolutely. No question about it. Whether the shoes we see on the market right now with the new carbon plate technology is the way to go, I don't know the answer to that. I know I did a lot of work with this. I know that when I made shoes too stiff using carbon fiber, I saw Achilles problems, calf problems, hamstring problems, patella tendon problems. I saw those kind of issues. Could it propel you to be faster? Yes, but the long-term effect on the muscles, I don't know. I mean, my verdict is still out on that. But I do know that it is possible to make you faster with a shoe. Now, in the 1890s, in the track and field rule book, there was specifically paragraphs written about not being able to use springs in shoes. Well, so we look at it now and we say, well, these are springs. Can we use these, or should these be legal? Well, if we look at the shoes that go back to Pavo Norby that he had in the 1920s, basically they were shoes with maybe a leather sole, or what they might have called plim soles, where they had some gum rubber for traction on the bottom. Well, if you look at that shoe and then you look at, say, what I started running in back in the late 60s and 70s, and then you look at today's shoes are springs, even if you don't put any carbon plate in them. Today's shoes are so much springier, so much livelier, allow you to train so much harder, so many more miles without getting the abuse that we got back then. If you take a shoe that we had just in my era, I'm not talking, 100 years ago. I'm just saying in my era, if you put a shoe on that some of us train hundreds of miles a week in, and you were to run across a parking lot today, you would not want to do that. You say, how the heck do you run in that? So there's constantly an evolution in equipment. And right now we are seeing a big deal. Now, should this be legal? I don't know the answer. But I'll say this, that records are meant to be shot for. People are meant, that's why you put records out there, to motivate other people to shoot for those records. I just don't know that you can't compare an athlete of this era with one 20 years ago, with one 20 years before that, and so on, because of the technology and advancements. I think we are at a stage of revolution. We're going to see so much happening now. I'm so glad to see the manufacturers, all the manufacturers, not just one, but all of them retooling up, understanding that composite fibers are the way to go. I knew this years ago that if you could make a shoe out of composite fibers, not only could you keep somebody from getting hurt, you could actually let them train faster, harder. The shoes would last. For instance, on my project that I worked on, believe it or not, Oakley was going to get in the shoe business. They tested my midsole. Most foams have an energy return factor of 12 to 15%, but after 100 miles, they're down to about 8%. My project that I worked on had an energy return factor of 46%, and after 5,000 miles, it still had 46%. So we are definitely at a stage of evolution, revolution, whatever you want to call it. I mean, shoes are going to come even farther exponentially probably than they have come, but we are majorly advanced over where we were in the 70s.
It sounds like you're not too concerned about technology ruining the purity of the sport, or worried about, stopping the progress of this technology. I mean, but you also said you don't really know where the line should be. So it seems like there's two ways to look at this. On the one hand, you could say, well, we got to draw a line on this technology because pretty soon we're going to have people running on trampolines and it's not running anymore. And so we got to make rules and regulate shoes, as far as competitive Olympic, elite athletes are concerned. But I guess the problem there is wherever you do draw the line is going to be pretty arbitrary, because we've already come light years ahead where we were, just like you said. But then on the other hand, you could say, and you hear this argument when it comes to performance-enhancing drugs is, look, it's just make it an even playing field, make it whatever it is available to everybody, make it free. Everybody has their own individual choice, and then as long as everybody's on the same playing field, it really doesn't matter, because it's not like you can compare, like you just said, you can't compare today's records to 50 years ago anyway. So what's the difference? Do you think there is a point of like, all right, that's too much?
Well, yeah, all right. So the IAAF, the International Athletic Federation, decided that, yes, they got to put some limits on this. All right. Coincidentally, the major manufacturer that has the most money in the game, their shoe that they were promoting was 40 millimeters thick. I'm sorry, 39.5 millimeters thick, I believe it was. So the IAAF said, okay, shoes can't be more than 40 millimeters thick. So that shoe then fit under the limit. Okay, so now all the other manufacturers can say, okay, we can do that, but we have to stay within that. I mean, as you can imagine, if you take it to the extreme, have you seen those things? I don't know what they're called, where you run on looks like a rollerblade, but it's got big springs on the bottom, and your stride length is like 3 times normal or whatever. Obviously, we don't want to get to that point, but so there's an arbitrary line that's been drawn now at 40 millimeters thickness for a shoe. Okay, well, this is as they say, slippery slope. I mean, we want to see people perform their best. But what I'm more concerned about now is not just speed, but I want to see runners not get hurt. I don't want to see technology that makes you faster but gets you hurt. I don't know if anybody ever saw the movie The Jerk, where Steve Martin was this character who invented a thing for your eyeglasses. where you could pick your eyeglasses up with a thing that's stuck on the bridge, and you never touched the earpiece, so you didn't ruin your eyeglasses, and you put them on a shelf, and they would stay in place. Well, he became a gazillionaire. Everybody loved him and so on. But after a year or two, everybody became cross-eyed. So I don't want to see technology get to the point that it makes people faster, but gets people hurt. I want to see people enjoy the sport more. And if running in shoes that give you more spring and keep you from getting hurt, that comes along, I think that's great.
Okay. So in your personal experience with your customers and your athletes, what are the kind of most common ailments or issues you see walk in the door that are related to, the wrong shoes or, injury related, that kind of thing?
Yeah, the injuries over time, I've been doing this 42 years. And over 42 years, I've seen injuries in the beginning, in the early stages. I used to see stress fractures, and shoes didn't have any cushioning, or not much cushioning. I see stress fractures, I see shin splints. Okay, well, as more people got into the running world, and people, and this is not a derogatory term, but as less competitive people got into the sport, they weren't as concerned about competition as they were just running. They weren't buying the shoes that manufacturers had designed for the competitive athletes. They were looking for something with more cushioning, for instance. So in the late 70s, we saw shoes get thicker. And when shoes got thicker, they became stiffer. So we started seeing shoes get thicker and stiffer, and people having Achilles and calf problems. So then what we realized, the manufacturers realized is, if we lift up the heel, we give more heel-to-toe drop, we can do away with that Achilles and calf problems. Now, the kicker there is that changes your other biomechanics and tells your pelvis and your lower back into a different position. But that kind of became the norm, and when the big manufacturers do that, then everybody else follows suit, and all of a sudden everybody's doing the same thing. So as shoes got thicker and stiffer and higher heel-to-toe drops, what I started seeing is more issues like with piriformis, patellar tendonitis, upper hamstring, like at the ischial tuberosity, the soleus muscle, plantar fasciitis. Well, as Joe knows, because Joe worked with me before, when I see somebody with those problems, I try to get them in a shoe that lets their foot function more efficiently, lets them go through their normal range of motion, and we can usually take care of that through, if the shoe doesn't do it by itself, I can take it back to the workbench, and I can perform modifications to make that happen.
Very cool. So what is the most common type of modification you're making for these problems nowadays?
Well, in the beginning, I would perhaps just throw more cushioning into the shoe, because shin splints and stress fractures and so on. As things progressed, what we hear today, the term overpronation, they didn't used to make shoes for that. So one of the next modifications I used to do was to actually build a medial post, a plastic bridge on the medial side of the shoe to prevent the foot from rolling in. Now, of course, manufacturers have copied that, and they do that. So again, as we've progressed along the route, and shoes have gotten thicker and more cushion and so on, one of the things that I've seen, although we're drifting back away from it now, is shoes where they were being stiff, we were having, like I say, piriformis, patellar tendonitis, ischial tuberosity, soleus, iliotibial band, and so on. And so I started siping the shoe in a horizontal lines up and down the shoe, and that would let the shoe flex more naturally. Now, I'm not talking vertically. I'm talking just horizontally. If you add grooves vertically, you can make the shoe less stable. But if you add horizontal grooves in the shoe, you can then make the shoe flex more naturally with your foot. Now, if we can make the foot move in a forward motion more efficiently, this is a weird concept to grasp. We actually make the foot more stable because we make the shoe go through the forward motion quicker, less chance to encounter resistance and move medially or laterally. So probably the modification that I do typically every day is adding siping to shoes. Now, manufacturers are starting to do that. Back not that long ago, the soles on shoes, the outer sole, the part that contacts the ground, was a solid piece of rubber. And so you would obviously siping it would be a drastic difference. Now, as shoes have the soles are put on in pieces, it's not as difficult. It doesn't make the shoe as stiff. It makes the shoe more flexible, but still a little bit of flexibility definitely helps the situation.
Okay. Do you want to talk about this patent you have? Or is that a whole can of worms, or what's the deal with your patent?
Well, that patent we're talking about was using composite fibers, and composite fibers include carbon fiber, graphites, Kevlar, and fiberglass. And so, interesting enough, I was in the store. I've always wanted to make shoes that make people, less prone to injury and make them faster. And a guy walks in my store one day. His name is Gordon Brown. Gordon Brown's a dang genius. Gordon is an engineer, and his specialty is composite fibers. And I had worked with composite fibers before, but I didn't have the know-how to make it all work. So he came to me and said he worked for a composite fiber company, and he said, do you think it has any can we use this, does it have anything, can we make athletic shoes and put composite fibers in them? I said, absolutely. And he had been thinking about using the composite fibers as structural reinforcement in the upper part of the shoe, the part that goes up on your foot, not underneath your sole, but to create more stability or more durability or whatever. Well, I said, well, hey, that makes sense. Yeah, cool. But, I had a lot of other ideas with it too, and he gave me bunches of samples of stuff he was working on. And anyway, I was playing around with it, and eventually I took a composite fiber of what we call E2 fiberglass with a certain particular epoxy, and which was in a one-strand fabric. It wasn't like woven fiberglass like you might imagine when you see fiberglass like Owens Corning insulation fiberglass. It wasn't like that. It was one strand of fiberglass that was spun around many, many times, thousands of times, and creating a platform. And so, fiberglass is very, very light. But like I said about the pole vault pole, it can elongate and it can contract. And so, I was playing around with it and thinking about making propulsion plates, stuff like that. I did that. I actually, one day I said, hey, I wonder if this stuff, if it's thermosettable, can I take a curling iron and can I put basically sine waves in this glass, and what will it do? Well, I did that, and then I cut it into the shape of the inside of the shoe, like an insole in a shoe, and I laid it underneath the insole inside the shoe, put the insole back over the top of it, and my gosh, it was like running on springs. So, this is really cool. So then I was doing that for a little while, and then I said, well, wait a minute. What if I put it on the outer part of the shoe? So I would peel the outer sole off the shoe, and then I would take this sine wave, basically, of glass, stick it on the bottom of the shoe. We played around with a lot of different types of fibers, glass, and so on, and different epoxies and so on. But, I wish I could remember the guy that worked with us. But he worked on the suspension systems for performance, serious high-performance vehicles that were made with composite fibers. And he worked with us with some epoxies, and we actually were able to come up with a fabric that would not break. The problem we have when you put any composite fibers in shoes is you could get breakage. Well, he had done it in high-performance cars, so we knew it wouldn't break under the stress of a human being running. So anyway, so I took the outsole off a shoe, put the sine wave down there, glued the sole back on, and I was like, man, this is fantastic. This is, this. Plus, what I found out is that it made the foam last a lot longer. Say a foam normally lasts 400 to 500 miles. When I stuck this glass under there, I was getting much more spring, but the foam would last, thousands of miles. And I thought, wow, this is interesting. Well, then, we worked on that. We, patented or got the intellectual property, trademarked, and so on. And then I took the glass, took the two sine waves, and I actually glued them together. Now, this is prior to, you may be familiar with the company Mizuno that makes a wave shoe, but this is prior to that. We took essentially that concept, and we took two opposing sine waves, and we glued them together with a flexible bond. Now we actually had something really, really interesting. We could do away with foam completely in shoes, just put this double opposing sine wave as a midsole, and then stick an outer sole on it, and we had something amazing. Now, what I did learn, though, is if the plates were continual, we would have back of the leg problems, like I said, soleus and so on. So what I learned is we put these double opposing sine waves on the bottom of the shoe, as sections, small sections, so the shoe would still flex. And we said, "Oh, this is fantastic." We actually applied to the U.S. Patent Office. We got back this response like, "Nobody's ever done anything like this before. This is fantastic," which is not the normal comments you get from the Patent Office. Like they gave us approval. We got our patents, and of course we've done further work and trademarked other intellectual property concerning this. But when you do that, it gets published and everybody sees it. Anybody that's in the manufacturing business will see it. And we've seen so many people copy it with the looks, with foam, with rubbers, with plastics, and so on. But nobody has actually taken glass and done it with glass, probably because they don't have that genius that we had that was able to come up with the proper epoxy to do it. But anyway, I knew back then that we really were onto something. And now that I see every manufacturer using composite fibers as a way to propel the foot faster, I'm like, oh, thank God, finally, after all this time, it's been 25 years, finally, people are understanding that this is the way to go. If you can make a shoe completely out of composite fibers, the shoe essentially can, you can make a point where it never breaks down. And shoes breaking down and people wearing them too long is one of the major causes of injury.
That sounds like a tricky situation to get in. You getting into the business side of shoes and trying to take, something scientific, something creative, and then when you go to try to monetize that idea, it sounds like a whole different world you're probably stepping into. What has been your experience, from just like concept to actually something marketable?
Well, yeah, there's the tricky thing. So back in the late 80s, I tried to start my own shoe company. I had a concept that coincidentally there was another company that was also working on something similar, which I wasn't familiar with, but I was developing this concept, and I was going to start my own shoe company. I had an agent that was working in Taiwan, and he had done some other work for me when I was a buyer for Athletic Attic. I bought for a bunch of stores, and I would give him a design. He would go to a factory, have it designed, and we would bring it in the store because we had enough stores that we could buy what we call container loads. So I had some ideas, and I went to him and I said, "Can you get this made?" Now, it was a technology that nobody was up to par with. Nobody was up to the intellectual capacity to do it, so they have to relearn the process. So anyway, I worked for a while, probably, had my regular job, but I was doing that on the side and worked for a couple years doing this. So I had a little bit of experience with trying to work in that side of things. What I quickly learned is you can go through a lot of money really fast trying to get prototypes built and so on like that, and that you find out there are a lot of unscrupulous people, not just in our industry, but in producing stuff. If you're going to go to Taiwan or any foreign country to make product, you can, Anyway, I just couldn't follow it up anymore. I didn't have the resources to do it. But coincidentally, all my ideas that I had submitted eventually came out on the market under different brands. And actually, one of the manufacturers actually came out with a shoe model with my brand name as the model of that shoe.
Are you able to say what that brand name is?
Well, my brand name was Harrier. Harrier, which in Europe, Harrier means cross-country runner. But also at the time, the jet was being developed called the Harrier, which would take straight off of the ground and not use a runway. So I thought most people didn't necessarily know Harrier as a cross-country runner, but they knew Harrier the jet.
Oh, interesting. Well, that's pretty impressive, just the fact that you were basically a one-man show, doing research and development, product development, marketing, and, as opposed to that sounds like something that's normally done in organizations where there's boardroom meetings and huge, acres of lab equipment and stuff like that. It almost sounds unreal, the process of trying to make that happen.
Well, yeah, that's why it didn't happen. but actually, so I was very lucky. Again, I went to work for Athletic Attic, which was, again, the first running store chain in the United States. Eventually, we had over 200 stores. So although I didn't necessarily always buy for 200 stores, I bought for a lot of stores. And so I had buying power. I mean, even I didn't have resources. I had buying power to give to try to produce shoes and get into the stores. And so I already had those connections. I was very lucky there. And I really credit Marty LaCory and Jimmy Carnes, who started Athletic Addict, and especially giving me an opportunity in the business, got me all these connections. And honestly, I met them through my brother Dave, who had already worked for them. So I was very lucky. I mean, it's all, the world all spins around by who you know. And my brother really introduced me to Marty and Jimmy, and that all got all of us started. And that's how all that happened. It got me, got all that to go on, and made me realize you can make this happen. If you get enough people to help you, you can make things happen. Again, moving into the patent with Gordon. So with Gordon working for a major manufacturer of composite fibers, I couldn't have done that myself, but he could provide me the composite fibers. I could go out to my garage with my tools and I could build stuff. I could never have built the composite fibers myself, but I got the manufacturers to send me shoe parts that then I could put my stuff in. They would give me an upper, for instance. I could then glue my stuff in, put an outer sole on it. Luckily, I didn't have to tear apart too many shoes to do this. I was being provided parts by the shoe manufacturers.